People often ask me what the most defining moment in the history of NVIDIA was. They expect me to talk about the launch of the H100 or the day we reached $1 trillion market cap. But the truth is, the most important moment was when we were just 30 days away from going out of business. It was 1997. We had already failed once with our first architecture, the NV1. We had spent all our money and we were essentially bankrupt. We had a contract with Sega to build their next generation console chip, but we realized halfway through that our technical approach was wrong. It was fundamentally incompatible with the way the industry was moving toward Windows and DirectX. If we finished the chip, it would be obsolete. If we didn't finish it, we wouldn't have the money to survive. I had to go to the CEO of Sega, a man who had every right to be furious with us, and I had to tell him the truth. I had to ask him to pay us in full for a contract we couldn't complete, just so we could have the capital to pivot and try one last time. That required a level of humility that is hard to describe. It was the realization that our survival depended on admitting our failure and asking for help. He agreed. That money gave us 6 months of life, and in those 6 months, we built the Riva 128. We ran. We didn't walk. We worked as if our lives depended on every single transistor because they did. That experience burned a philosophy into the DNA of this company. We solve the problems that nobody else wants to touch, and we do it by questioning everything from first principles. Today, we are at a similar crossroads, not just as a company, but as an entire civilization. We are standing at the edge of a cliff, looking at the end of traditional computing as we know it. For 60 years, the world has operated on the same basic idea. You write a piece of software, you give it instructions, and a central processor executes them one by one. This is what we call traditional programming. It served us well. It built the internet, the smartphone, and the digital world we live in. But that era is over. The buy traditional programming moment isn't a marketing slogan. It is a mathematical reality. Moore's Law, the idea that we can just keep making transistors smaller and everything will magically get faster, is dead. It's not just sleeping, it's gone. The physics of silicon have hit a wall. If we continue to rely on traditional CPUs and traditional coding, the energy cost of computing will bankrupt the planet before we solve our most pressing problems. We have reached the limits of what human written code can achieve. Think about the complexity of the world. Think about the weather, the movement of a robotic arm in a chaotic warehouse, or the folding of a protein to cure a disease. You cannot write enough if-then-else statements to describe the complexity of the physical world. You can't code your way out of the climate crisis using traditional software. This is why NVIDIA has spent the last 30 years building a completely different way to compute: accelerated computing. We realized early on that if the CPU couldn't get faster, we had to change the architecture. We had to move from serial processing to parallel processing. We had to build a stack that wasn't just about hardware, but about the marriage of silicon, algorithms, and software. This leads us to the most significant shift in our lifetime: the introduction of physics AI. For the last decade, we have been amazed by AI that understands language. Large language models are incredible. They can write essays, they can generate images, they can summarize data, but language is just a human construct. The universe doesn't speak English, the universe speaks physics. If we want AI to truly transform the world, not just the digital world, but the physical world, it must understand the laws of gravity, of friction, of fluid dynamics, and of electromagnetism. Traditional programming tried to fake physics through approximations. Physics AI learns the actual behavior of the world by observing data and simulating reality at a scale that was previously impossible. When I look at what we are doing with Omniverse and our digital twin technologies, I see the replacement for traditional engineering. In the old world, you built a factory, and then you spent years fixing the mistakes you made in the design. You programmed the robots, and you hoped they didn't hit anything. In the new world, the factory is a digital twin first. It exists in a world of physics AI where every photon, every collision, and every workflow is simulated with absolute precision. We are teaching AI to be a social animal of the physical world. It learns to interact with machines, with humans, and with the environment before it ever touches a piece of steel in the real world. This is the revolution. We are moving from a world of software-defined everything to AI-defined everything. The traditional programmer of the future won't be writing lines of C++ or Python to tell a car how to turn. They will be the curators of the intelligence that learns how to drive. They will be the architects of the environments where physics AI matures. This is a fundamental change in our first principles of work. At NVIDIA, we have always maintained a flat structure because of this. I don't want a hierarchy where information takes weeks to travel from the engineers to my office. I want a company that operates at the speed of the technology we are building. We have no parts or phases. We are one continuous story of innovation. Our organization is designed to be a neural network. Information flows everywhere, and decisions are made where the expertise lives. I tell students and young founders, don't look for the easy path. Don't look for the job that has a clear description and a comfortable routine. I wish you doses of pain and suffering, because that is the only way you will develop the resilience to face the impossible problems. If a problem is easy, it's already solved. If it's hard, it's an opportunity. We took the hard path with CUDA. For 15 years, we invested billions of dollars into a platform that the world didn't understand. We were ridiculed. We were told that GPUs were for games and nothing else, but we saw the first principle. The world needs more math, and it needs it faster and cheaper. We didn't walk toward that vision. We ran. We ran through the skepticism, we ran through the technical failures, and we ran toward the future of the AI factory. The AI factory is the new data center. In the past, data centers were places where we stored files. In the future, they are refineries. The raw material is data, and the finished product is intelligence. This is the new industrial revolution. In the first industrial revolution, we turned water into steam to create mechanical power. In this one, we are turning data into tokens to create digital intelligence. And just as the steam engine needed a new kind of physics, this new revolution needs physics AI. It needs a computer that doesn't just calculate, but understands the world it is calculating for. This is why we are introducing technologies that allow AI to simulate weather patterns with 1,000 times the efficiency of traditional models. We are introducing Earth 2, a digital twin of our planet, to predict the future of our climate. Traditional programming could never do this. It simply isn't powerful enough. This transition requires a sense of urgency that is visceral. Run, don't walk is the only pace that matters when you are reinventing the foundation of human civilization. If you are a company today and you aren't thinking about how to turn your data into intelligence, you are the horse and carriage in the age of the Model T. If you are an engineer and you aren't learning how to collaborate with AI, you are using a slide rule in the age of the supercomputer. The shift is that fundamental. We are moving away from the era of human-coded complexity to AI-discovered simplicity. One of the things I am most proud of is that NVIDIA is not just a chip company. We are a systems company. To solve the problem of physics AI, you have to build the entire stack. You have to build the DGX systems, the InfiniBand networking, the software libraries, and the foundational models. You cannot optimize a revolution one piece at a time. You have to have a vision for the whole thing. This is what it means to build things that didn't exist before. We didn't wait for the industry to define what an AI supercomputer should look like. We defined it. We built the architecture that we wanted to use ourselves. We were our own first customer. This leads us to a very important realization. The most valuable thing you can have in this new era is not experience, but the ability to learn. Experience is often just a collection of old habits. In a world where the rules are changing, your habits can be your greatest enemy. You have to have the humility to realize that everything you knew about programming 10 years ago might be irrelevant today. You have to be willing to be a beginner again. I still feel like a beginner every day. I walk into our labs and I see things that I don't fully understand, and that is the most exciting part of my job. If I understood everything, we wouldn't be innovating. Innovation happens at the edge of your understanding. It happens when you are willing to look at a problem and say, I have no idea how to solve this, but I'm going to find out by going back to the first principles. We are seeing this play out in the world of robotics. Traditional robotics was about precise, repetitive movements in a controlled environment. Physics AI allows for general-purpose robotics. It allows a machine to enter a room it has never seen, pick up an object it has never touched, and perform a task it wasn't specifically programmed to do. This is the more for the world that we are introducing. It's not just faster chips, it's a new category of existence for machines. We are giving them the ability to perceive, reason, and act within the constraints of our physical reality. This will change everything from how we grow food to how we care for the elderly. It is the ultimate expression of our work, building the intelligence that helps humanity solve its most intractable problems. I want you to think about the iPhone moment of AI that we are in right now. When the iPhone came out, it wasn't just a phone. It was a platform that enabled a million other things to happen. It enabled Uber, it enabled Instagram, it enabled the mobile economy. AI is that, but for the very concept of intelligence, and physics AI is that for the physical world. We are building the platform that will enable the next generation of entrepreneurs to build companies that we can't even imagine today. If you are that founder who feels like they are doing everything wrong, I want you to realize that you are in the best possible position. You aren't tied to the old ways. You aren't trying to protect a legacy of traditional code. You are free to build on the new foundation of accelerated computing and physics AI. The scale of what we are talking about is hard to wrap your head around. We are talking about a $100 trillion global economy that is about to be re-instrumented with AI. Every car, every building, every medical device, every piece of software is going to be reinvented. This is why the urgency is so high. This is why we don't have time for bureaucracy or long-term planning that doesn't involve immediate action. We have to build, we have to test, we have to fail, and we have to learn at the speed of the silicon. Silicon is just the canvas, but the art is in the architecture. And that architecture is now demanding a complete departure from everything we thought we knew about building systems. When I say buy traditional programming, I am talking about the liberation of the human mind from the drudgery of low-level instruction. We are moving to a world where the computer understands the intent, the context, and most importantly, the physical constraints of the task at hand. This is the heart of what we are doing with Blackwell and the NVIDIA Inference Microservices, or NEMs. We are creating building blocks of intelligence that you can assemble like Lego. You don't need to be a kernel engineer to deploy a world-class AI anymore. You just need to have a problem worth solving and the first principles to guide you. This shift is why I am so obsessed with the idea of the AI factory. Think about the history of human progress. Every time we found a new way to harness energy, we built a factory to refine it. The steam engine led to the textile mill. The internal combustion engine led to the assembly line. Now, the GPU is the engine of the intelligence revolution, and the data center is the factory. But this isn't a factory that produces cars or clothes. It produces tokens of intelligence. These tokens are the most valuable resource on the planet because they can be used to solve any problem in any language, in any domain. This is the more we are bringing to the world. Not just more pixels, but more wisdom, more capability, and more time for humans to be creative. The transition to physics AI is the most difficult engineering challenge we have ever faced. It's one thing to teach a computer to recognize a cat in a photo. It is a completely different thing to teach a computer the subtle, complex interactions of a surgical robot inside a human body, or the aerodynamic turbulence around a new type of electric aircraft. These are impossible problems because the math is too heavy for traditional CPUs. We have to accelerate the entire process. We have to build simulators that run at the speed of reality or faster. We have to create synthetic data that is so accurate that the AI can't tell the difference between the virtual world and the real one. This is what we call sim to real, and it is the bridge to a future where robots are as common as smartphones. I often reflect on the culture we've built at NVIDIA. People ask me how we keep innovating after 30 years. It's because we haven't forgotten the pain of being 30 days from bankruptcy. We still have that run, don't walk mentality in everything we do. We have a structure that is incredibly flat because I believe that the closer you are to the problem, the more likely you are to have the right answer. In a traditional company, an idea has to die 10 deaths before it reaches the CEO. At NVIDIA, if you have a breakthrough in a lab at 2 a.m., it can be on my desk by 8 a.m. We thrive on the honesty of failure. If something doesn't work, we don't hide it. We dissect it. We learn from it. We use it as fuel for the next iteration. That resilience is our competitive advantage. It's not just our chips, it's our character. The work of your life should be to build things that didn't exist before. If you are just making a 10% improvement on what already exists, you are wasting your talent. You should be looking for the 0 to 1 moments. Physics AI is one of those moments. It is a fundamental expansion of what a computer is. For the first time, we are giving machines a sense of presence in the physical world. This will redefine manufacturing. It will redefine logistics. It will redefine how we interact with the environment. We are building the foundational models, like GR00T for humanoid robots, that will allow machines to learn by watching humans, just as a child learns by watching its parents. This isn't just programming, it's teaching. It's a completely different relationship with technology. I know that change can be frightening. When people hear buy traditional programming, they worry about their jobs or their skills. But I see it differently. I see it as the ultimate empowerment. We are giving you a superpower. We are giving you a digital collaborator that can handle the complexity so you can focus on the vision. The most successful people in the next decade won't be the ones who can write the most lines of code. They will be the ones who can ask the best questions, who have the clearest first principles, and who have the grit to keep going when the AI tells them their idea is impossible. We are building a future that is not just smarter, but more sustainable. Accelerated computing is the only way to reach our climate goals. By moving from general-purpose CPUs to specialized GPUs, we can reduce the energy consumption of data centers by orders of magnitude while increasing their performance by thousands of times. This is the efficiency paradox that we are solving. We are proving that you don't have to choose between progress and the planet. You just have to choose a better architecture. You have to be willing to leave the old, inefficient ways behind and run toward the era of accelerated intelligence. I look at the young founders today, and I am filled with hope. You are starting your journey at the most pivotal moment in human history. You have the tools of a god at your fingertips. You have the ability to simulate entire universes on a single rack of Blackwell chips. You have the ability to harness physics AI to solve problems that have plagued humanity for centuries. Don't waste this moment. Don't be afraid to do everything wrong if it means finding a new way to be right. Remember that every great thing NVIDIA has ever done started as a failure or a crazy idea that the industry rejected. The future is being written right now in the labs, in the startups, and in the AI factories around the world. It is a future where intelligence is abundant, where robots help us do the hard work, and where we have the tools to protect our planet for generations to come. This is the world we are building at NVIDIA. We aren't just a part of the story. We are providing the ink and the paper. But you are the authors. You are the ones who will take this technology and turn it into something that changes lives. As we move forward, keep that sense of urgency. The window for innovation is wide open, but it won't stay that way forever. The world is moving at a pace that is almost impossible to track, and the only way to stay ahead is to keep running. Don't walk. Don't wait for the technology to become mature. The maturity is in your willingness to experiment. The maturity is in your resilience. Thank you for joining me on this journey. I truly believe that the best work of our lives is still ahead of us. Before we close, I want to invite you to be a part of this community. If you found this vision compelling, please subscribe to the channel and give this video a like. It helps us reach more people who are ready to build the future. And please, I want to hear from you. What are the impossible problems you are trying to solve? How are you using physics AI to change your industry? Leave your questions and your thoughts in the comments below. I promise you, I will be reading them and I will respond quickly. I want to know what you are building. The logical conclusion is irrefutable. The world is no longer being built by lines of code, but by the laws of physics and the power of accelerated intelligence. This is the new industrial revolution. We have moved past the era of traditional programming into an age where imagination is the only bottleneck. The tools are here. The architecture is ready. The future is waiting. Run, don't walk.